Very good morning, friends. Today in the morning, we will see the very basic problem in kinetics. So, kinetics, as I told in the introduction of dynamics, so in kinetics, we have to add one more force, that is the inertial force, to make to solve the problems to keep the body which is in motion in dynamic equilibrium condition, right? So this is the problem. You can see this problem. I have a block having 30 kg, okay, 30 kg, which is equivalent to 294.3 Newton weight. It is tied with a string and it is connected with another block which is 120 kg, which is equivalent to 1177.2 Newtons weight. The two bodies are connected with this string, and the second body, the bigger body, is pulled right side with a force P. What is that force P? If the mu1, body 1, that is coefficient of friction, is 0.4, body 2 coefficient of friction is 0.25. So how to solve this problem? Okay, so here you can see I am going to investigate the very first body here. This is the P, we have to find it out. Finally, we will find out what is that P. So here, this body 1 I am going to investigate. That I have drawn the free body diagram for that. You can see here, both the bodies are moving to the right side. So that is the condition. Both the bodies are moving to the right side. So definitely there will be a left side frictional force. What we have seen in the previous module, friction module. So definitely there will be a frictional force in the left side. So you see here, in this body, if I terminate the string, there will be a tension. That tension I can decompose into T cos 30 and T sin 30. Right. So T cos 30 and T sin 30 is 0.5 T. T cos 30 is equal to 0.866 T. Right. So you can see here the weight is acting downward, that is 294.3 newtons, and there will be a normal reaction N1 is acting. And since the body is moving right side, there will be a frictional force, that is 0.4 into N1. So up to this is a friction problem. It is similar to the friction. Now, since the body is moving, it is a dynamic condition. So to keep the body in dynamic equilibrium condition, I have to apply one more force, that is the inertial force MA. What is that? That is the mass into A. What is mass? 30. For this body, mass is 30 kg. A is the acceleration. So for both the bodies, the acceleration is going to be same. So A is the acceleration. So apart from frictional force, I will be having a inertial force MA. I have to add it opposite to the movement direction. So you can see the free body diagram here. This is the particle block. It is considered as a particle, and there will be a upward force T sin 30 plus N1, downward force 294.3, and left side force will be 0.4 N1 plus 30A. Right side force will be T cos 30. So what I can do it, I can find out T, this vertical component. If I, the particle to be in equilibrium in two dimension, is there are two conditions, that is summation of f of x is equal to 0, summation of f of y equal to 0. Summation of f of y equal to 0, if you see, T sin 30 is plus n1 is equal to 294.3, that is 0.5 T plus n1 equal minus 294.3 is equal to 0. So n1 will be 294.3 minus 0.5 n, 0.5 T. Then in the horizontal force, if you take 0.866 T minus 0.4 n1, so you can see here 0.4 n1, that is 0.866 T is positive, negative is minus 0.4 n1 minus 30A. You can see here 0.866T minus 0.4N1 minus 30A is equal to 0. In this equation, the N1 I will substitute the previous equation. From the previous equation I have got the N1. That N1 you substitute it here. I will get an equation as T minus 28.143A is equal to 110.432. This is my first equation for the block 1. So coming to block 2 mass is 120 kg, weight is 1177.2 Newton. So there will be a normal reaction N2, and there is a force P which is pulling right side is 600, that is given in the problem. Right. Then left side there will be a tension acting 30 degree to the horizontal. So this will be 30 cos 30. This will be T sin 30. The vertical component will be T sin 30. And since the block is moving right side, there will be a leftward frictional force. What is that? For this block, the coefficient of friction is 0.25, 0.25 and 2. 0.25 and 2. Then this body is moving. So to keep this body in dynamic equilibrium condition, I have to supply a MA to the opposite to the movement direction. Apart from the friction, that MA is nothing but mass into acceleration. That is, mass is 120 into acceleration A. So for this condition, the body to be in equilibrium, I will be having another equation. By solving this second body, I will be having another equation for N2 is equal to 1177.2 plus T sin 30. So by substituting this in the first equation, summation of f of x is equal to 0, I will be getting t is equal to 1t plus 121.09a is equal to 308 308.476. This is my another equation I have got from the second body. Right, this is T plus 121.09A plus is equal to 308.476. So this first equation is this, second equation is this. So in this two equations I have got, so two equations I will have two unknowns T and A. Here also I have two unknowns T and A. So two equations I have two unknowns. Very well I can solve it in calculator. So I will find the final T as tension as 147.778 Newton, and acceleration of this body, that is what it is asked in this problem. Since the body is moving, what is the final acceleration of the body? So acceleration of the body will be 1.327 1.327 meters per second square. Thank you.